All right, so now we are on the back of our study guide here. For some reason, I can't get my little webcam to work, so you can just like picture my face over here in the bottom right part of the screen. All right, so on the back here it says, first of all, when I bold and I underline instructions, there is a pretty good chance that I actually want you to read it. Okay, so it says for each of the following calculations, first write the formula, then plug in what you know, including units. Lastly, plug into the calculator and solve. Make sure your answer has units and it's in a box. Okay, so let's kind of like digest these for a second. It says first write the formula. So let's say, okay, so let's read our first one. It says, what's the speed of a police car? So obviously I'm looking for speed. And let's say I forgot what the formula for speed is. And I would go over here to my notes. And here I can see speed equals distance divided by time. So I first write my formula. S equals D divided by T. Okay, then plug in what you know. S equals, and as far as units go, you can just maintain these units, whatever I happen to give you. You don't have to like transfer it into seconds or, centimeters or anything like that, okay? So just keep whatever units that I give you. So we go 30 miles because that is the unit of distance, and we go 0.3 hours. And then it says plug it into the calculator. So if I needed a calculator to do this, then I would do 30 divided by 0.3, and that gives me 100. So S equals 100, and then I would do mile. You could do mph or miles per hour or m over h, whatever. Okay, and then plop that thing in a box. Okay, so that's our first one. All right, 13 says, what's the speed of a roller coaster if it travels 600 meters in 3 seconds? So we go S equals D divided by T. S equals, this is our distance here is 600 meters, so 600 divided by 600 meters divided by 3 seconds. So then our speed equals, plop my calculator up here, 600 divided by 3 equals, of course, 200. 200 meters per second in a box with units. All right, number 14. As an osprey migrates south for the winter, she covers 1,000 miles in 3 days. What is her velocity? Now, recall the formula for velocity is the same exact as the formula for speed. The only difference is that it takes into account direction. Right here we have speed equals distance divided by time. Velocity is distance divided by time in a specific direction. Okay, so here we have V equals D divided by T with a direction. That's my formula. And then we have V equals 1,000 miles in how long? 3 days. And her velocity equals, we're going to go 1,000 divided by 3 is 333.3 repeating. 333.3 repeating. We're going to go miles per day. And I've gone off the paper a bit, but you get the point, in a box. Okay? I really, really encourage you to make sure that you are actually writing out your formula, even on the test. Okay? Write out the formula. No, I'm not ever going to know whether you did it or not, except if you get it wrong, there's a pretty good chance you did not write out the formula and plug in what you know. All right, number 15, the Browders honeymooned in Maine. True fact. They left Virginia and drove 846 miles to Bar Harbor, Maine. True fact. Let's go. We're looking for a velocity here, so we go V equals D divided by... Oh, you know what? Did I forget something up here? Sure did. What did I forget right here? You're probably all like, she forgot to put direction. You're right, I did. S-O-U-T-H. Bam. Done. Everybody makes mistakes. It's okay. All right. We fix them. That's what matters. Here we go. See, I wouldn't have known that if I hadn't written my my formula. See what I'm saying? That's what we need to do. V equals d divided by t in a specific direction. So V equals, my distance is 846 miles, and we have 16 hours. Now notice, up to this point in your education in my class, I have been harping on the metric system. And don't get me wrong, I still love the metric system. But when we're talking about things like velocity and speed and stuff like that, it's okay if I use some more traditional types of units. You don't need, like I said before, you don't need to transfer them into SI units. All right. So, and this, by the way, let me go ahead and plop it in here. If I left Virginia, it doesn't, and you're thinking right now, like, oh my goodness, it doesn't say anything about direction. Think about it. Take your little map of Virginia, map of United States. A little bit of Texas, a little bit of Florida. Oh yeah. By the way, right now, I am bada bam right there in San Diego, California, and you are bada bam right here in Smithfield, Virginia. So, what we did, we went north. Or if you want to say, like, north, a little bit east, that'd be fine too, okay? But it's north. Alright, so here is the deal. We go 846 miles in 16 hours. And so we need to plug, oh, this would be north. And we need to plug this bad boy in. 846 divided by 16. 52.875. Now notice, see how that is like a nice, like tight, it's only got 3, tenths, hundredths, thousandths. It goes to the thousandths place, right? Fine by me. Leave that just like it is. You don't necessarily, it's not entirely wrong if you were to round it up, but since it kind of like ended itself, go ahead and write all those numbers. 52, so V equals 52.875 miles per hour. And it is crucial that you put the direction up in there. If you do not put the direction in there, it is entirely wrong. Okay. There is no number 16. There used to be a 16, and then I thought it was a dumb question, so I took it out and put a smiley face instead. I hope you're having a great day. Number 17, define and describe velocity. So, okay, so let's say I was like, I don't know what velocity is. Velocity is, in fact, speed in a particular direction. Okay? Speed in a particular direction. Let's get this back up. All right, number 18. So, like we said before, speed and velocity, same thing, right? The only thing that's different is that velocity takes into account direction. All right, number 18 says describe 3 ways to change acceleration. So let's say you're like, I have no clue. Let's check it out in this PowerPoint right here. Changing acceleration. There are 3 ways to do it. One is speed up, the other is slow down, the last one is change direction. Note, these PowerPoints that I'm bringing up, of course, are on my website, PS.10 resources. I would strongly encourage you to review those very, very carefully. So, 3 ways to change acceleration. We can speed up, we can slow down, and we can change direction. Let's speak to that for just a minute. First of all, the easiest one to remember, I didn't have to tell you that when somebody speeds up, they're accelerating, right? You already knew that before you came to me. However, these last 2 are a little bit more counterintuitive, means it doesn't necessarily come to your mind first thing. Okay, so anytime somebody slows down, they are accelerating. Why? Because the definition for acceleration is nothing more than a change in velocity. Maybe they're decreasing their velocity. Okay, so deceleration sounds like in English like it'd be the opposite of acceleration, but not for real. Deceleration is a form of acceleration. Deceleration is a form of acceleration. And then the last one, changing direction. Okay, so you can be going, 55 miles an hour north, and then just bloop, you start going 55 miles an hour northwest. Speed has not changed at all. However, acceleration has changed. Therefore, it is accelerating, and the reason for that is because it has changed its velocity. All right. All right, number 19 says describe and define velocity. That kind of looks a whole lot like number 17. So my bad. That was kind of a gimme too. All right, number 20. Moving into our last topic here, which is Newton's 3 laws of motion, which is what we covered last week. It says, describe Newton's first law of motion. Also, what is another name for this law? So we take a look at this PowerPoint right here, which is, of course, on my website. And here it is, right there. It says, an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon, at constant velocity, FYI, unless acted upon by an unbalanced or outside force. Motion leads to motion, rest leads to rest. And then it is also known as the law of inertia. Okay, so let's just write all of that down right over here. So one more time, just in case you haven't memorized it, an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an unbalanced force. This is known as the law of inertia. All right, 21 says, what is an example of Newton's first law of motion? So take a look here, and I see some examples. Okay, so these pumpkins right here are not going to move unless they are acted upon by an unbalanced force. An elephant has more inertia than a mouse. We're going to talk. Than a mouse, and we're going to talk about why that is here in just a minute. Not sure why I have this little circle thing going here. All right, so an example of Newton's first law of motion would be let's see, a pile of pumpkins. Pile of pumpkins doesn't move unless acted upon by an unbalanced force. Okay, and next one, let's see, it says define inertia. Oh, I see. Inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. And I am almost going to run out of time on this video, so we'll start it with the next one.